In this video, we're going to learn how to add rational expressions. So consider this addition problem containing rational expressions. 3 over m squared minus 3m minus 10 plus 7 over m squared minus m minus 20. The fundamental concept or step in adding fractions is to find the least common denominator. And the least common denominator is the least common multiple of the denominators. Now when we talk about multiples, we're talking about factors, things that you multiply together. So what you need to do first is you need to factor each of these denominators. So our numerator stays the same. M squared minus 3m minus 10. That's a trinomial. Leading coefficient is 1. So we can go right to this. We need to find two numbers that multiply to be negative 10 and add to be negative 3. That would be negative 5 and positive 2. Okay, so you write it like that. Now bring your plus sign. The 7 stays the way it is. This again is a trinomial with the leading coefficient of 1, so it's going to be m and m. Now we need to find two numbers whose product is negative 20 and sum is negative 1. That's going to be negative 5 and positive 4. Okay, now we have to determine the least common denominator. What we do here is the least common denominator needs to contain at least each factor once. So m minus 5 must be part of it. M plus 2 must be part of it. We already have an m minus 5, so we don't need it again, but m plus 4 must be part of it as well. Now you look, and I'm just going to rewrite this first fraction. 3 over m minus 5 times m plus 2. And we say, okay, well, of the three factors in our least common denominator, which one is this missing? This is missing the m plus 4. So I need to multiply the denominator by m plus 4 in order to get that least common denominator. But remember, with a fraction, you can't just multiply the denominator by something. You have to also multiply the numerator by that. Now bring down the plus sign. Bring down the other fraction. Notice this one is missing the m plus 2 factor. Okay, a thing to keep in mind. The reason that this can be done. This m plus 4 over m plus 4, that's equivalent to 1. So we're not changing that fraction at all. This m plus 2 over m plus 2, that also is equivalent to 1. So again, we're not changing that fraction either. So we're actually not even changing this problem at all. All we're doing is we're rewriting these in a format so that you can actually add them. You need common denominators in order to add. So now we have 3, and I'm going to keep these separate for now, all over this common denominator. And then a plus sign, and I have 7 times m plus 2 all over this common denominator. And we could put them in the same order if we want as the other one. Don't cancel anything out here. Don't cancel out those m plus 2s or those m plus 4s, because then you're back where you started. So now we can write it, since we now have the common denominator, we can actually write this as one fraction, and I'm going to keep these separate for now. See, there's my plus sign. Very important if there's a minus sign in between. Over my denominator. Now we have to simplify this numerator, so we have to distribute the 3 here and distribute the 7 here. So we're now going to get 3m plus 12 plus 7m plus 14 over our denominator. Continuing to group like terms. 3m and 7m, those are like terms, becoming a 10m. Positive 12 and positive 14, those are like terms, becoming a 26. So we get 10m plus 26 over our denominator. Notice I'm keeping this denominator factored, which you should do. Now we just take one extra step and see if this can be simplified. So let's factor out the greatest common factor of the numerator, which is just a 2. And then we're left with 5m plus 13 over our common denominator, m minus 5, m plus 2, and m plus 4. Once in a while, you can actually cancel out a common factor here at the end, but you don't ever do it until the very last step. Since you can't cancel anything out, either one of these answers is acceptable.